Hello everyone, I want to make a quick review for your exam that is on Wednesday. So far we covered chapter 1 and chapter 2 on the aggregates. So that is what I want to go through and what you expect in your exam. So on chapter 1 we covered basically on the construction process, and the construction process in itself. First we need to understand how the different people working in the construction industry are associating with one another, be it the exchange of information, the way the different responsibilities that these people have, which ultimately will affect the selection of materials, the testing, the quality assurance, and things like that. So for example, if we have a project which has the owner, the architect engineer, the general contractor, the suppliers, and the subs, then you expect to have a slight relationship as the one that is shown on this chart right here. And this is what I asked you to do in your homework too. So if you understand that relationship, and this relationship actually is connected to how and which project delivery method that was selected to be used on that particular project. If it is the traditional kind of doing things, or the traditional project delivery method, so you expect that you have a relationship between the owner and the general contractor, then the suppliers and the subs who are working under the general contractor. And then of course you will have the testing labs, which will ensure that there is quality on the materials that you are using for that particular project. So this organization in itself, as I said, will ultimately determine who is responsible for the material selection, who is responsible for the approval, and who is responsible for the quality assurance of the materials. And then you have the document usually used in the construction industry, and that contains the specifications. So each material must have the specifications which must be adhered to by the general contractor, and thus it will also detail on how the inspection is going to be done and how the testing will also be done. So together with the specifications and the organization and the responsibilities, the construction process also entails that we keep our project within the schedule and within the budget. Okay, as much as we're doing that, we also need to ensure that our project is safe. Okay, and the safety of the construction workers is administered by the OSHA. Then specifically we want to see what is the role of the architect engineer, the technician, or the construction manager when within the construction arrangement. So in all this, we also need to have materials that are more sustainable. Okay, we have to care for the environment. So to design and to construct new and renovated buildings, we must use the most efficient material with the consumption of energy and the labor resources in mind. We also need to operate these facilities in a way that will significantly reduce the energy consumption and the production of the greenhouse gases. This will go all into more detail, even the way we dispose our waste within our buildings. We have areas where we can have a sign where we need to dump our waste, which can be recycled. And if you have things that cannot be recycled, do you want to mix them? Okay, so that goes again into the operation of our facilities in a way that is more sustainable. When we also choosing our construction materials, we need to choose the materials maybe that we can recycle or reuse when we are going to reconstruct our facilities. Then that begs the question, then why? So we need to look at the material qualities and the properties of our materials so that we make sure that they are more sustainable and they're going to achieve the purpose that they are meant to. So you need to understand these things, okay? So one of those quality is the strength, okay? And when we are talking about the strength, here we are going to choose a material that is more stronger to sustain the different loads that are going to be subjected to either our building or our infrastructure or wherever that project is. So these materials must withstand the different forces that will be acting on that structure. The second thing that we are looking at is the flexibility of our materials. Okay, so for example, if we were doing gas piping, for example, or we were doing our HVAC, the heating systems in our building, okay, so we need to use maybe the pipes which are more flexible, okay, to go through the different designs of our building, okay. So that will come into play when you're talking about how flexible our materials are, okay. So even for our masonry, okay, how flexible is it? And what are the environmental effects, okay, of our material? Is it consider things like the thermal conductivity, okay? Are you going to gain heat easily? Are you going to lose heat easily, okay? So where are you doing your project? Is it places where you're prone to have more summers or more winter, okay? So you have to look at those materials and say this material is meant to gain more heat, okay? So it's not good for this particular climate. Now this material is meant to lose more heat, and therefore it's not good for this kind of climate, okay? So these are kind of the qualities that you look at when you want to choose the material, okay? Still, you can look at things to do with modulus of elasticity, which is more engineering, okay? So you need to know and define what modulus of elasticity is. And I previously said that the modulus of elasticity is the ability of a material, okay, to expand and contract, okay? If you apply some force on a material and it expands, and when you withdraw that force, it returns to its original shape and size, okay, as long as the elastic limit is not exceeded, okay, then that material is said to have a modulus of elasticity. So then you start thinking about things like steel, things like plastic, things like good. Okay, for example, if you subject steel to heat, okay, that steel will expand, okay, and when you withdraw the heat, that steel will contract, right? As long as that material uh, does not exceed the elastic limit, okay, then we say that that material is elastic. Then you need to understand the relationship between the stress and the strain. Okay, you need to know how to calculate shear. Okay, shear. I didn't have the equal sign there. So the shear is supposed to be pressure. Okay, so pressure is just force. Okay, divided by the cross-sectional area. Okay, so make sure that you know how to calculate shear. Okay, and remember that shear is equal to pressure divided by the cross-sectional area. Okay, think about the proportional limit. Of course, we're not going to go into detail because I think that you have learned this in your other classes and you know what they mean. Okay, so make sure you go through these terms and be able to define them and be able to calculate shear. So where does the engineer or the technician fit in this whole construction process and materials specifically? So in order for an engineer, technician, or a construction manager to use materials properly, then one must first understand the natural characteristics of that material. They have to understand the variations in these characteristics, and they have to understand the way materials can be used in combinations with one another. Okay, so you have to know why the engineer, the technician must fit in this whole area of materials in construction. Then how will the owner know that they got what they paid for? That's why we need the inspections. Okay, so if I ask you why do we need inspections, so the first reason why we need inspections is because the owner needs to know that they get the value that they pay for. So the other reason for those inspections, you look at the product, okay, you look at the site, okay, and then you do the testing. So once you inspect the product, okay, then you also inspect that site, right? Then you do your testing. For the testing, we have different standards that we use depending on even the type of project. Okay, we have the ASTM, we have the ACI for concrete, we have ASHTO is for the highways. Okay, we have the AISC and we have the APA. So most of these standards will also go in line with the kind of material that we are doing and the type of project that we are working on. For all this testing, you have to decide which standard that you want to use, and are you going to do your testing in the field, or you're going to send your samples to an offsite lab. Okay, then are you going to have a QA or a quality assurance person? Okay, how are you going to control for your quality? Okay, so you must have those procedures. So those methods and test methods, for example, those acronyms, you need to know what they stand for. Okay, make sure that you know what those acronyms stand for. For example, the ASTM for the American Society of Testing and Materials, the ASHTO, which is for the American Association of State Highways and Transportation Officials. So all these you need to know what those acronyms stand for and what their main agenda is, okay? If they're meant for specific material or they're meant for specific projects. So we again then looked at the aggregates, and I combined the aggregates with the soils. If you look at your text, it more emphasizes on aggregates than the soils, but you need to review both the aggregates and the soils. So for the soils, I have my lecture notes up on Blackboard. Even for the aggregates, there are materials on Blackboard. They're the same thing, okay? Because soils and aggregates, they're sourced from rocks, okay? So soils, aggregates is the same thing, but the only difference that I put up for you guys is that for the soils you have the organic and the inorganic soils. And as I said, that the organic soils are not for the engineering purposes, and therefore our focus is more on the inorganic soils where we source our aggregates. Okay, so I introduced soils before the aggregates because I wanted you to understand what soils are and the soils that we need for the engineering purposes, okay? And that's why that was part of my introduction, where we get our aggregate from and what good aggregates that we use, and the particle shape, particle size, the moisture content, and looking at our mass volume relationships between the aggregates, okay? And it's, as I say, that the mass volume relationships are key because we want to see if we're going to prepare a sample where you have two types of aggregates, okay? So you want to see the different batches and the proportions that you want to use in order to achieve a combination of materials that you are working on. So there are many definitions in your text and on that chapter on aggregates, okay? So you need to know what the definition for the coarse aggregates, definitions for fine aggregates, definitions for gravel, definitions for sand, okay? Terms like gradation, okay? Coefficient of uniformity. So those are many definitions that you need to know under the chapter on aggregates, okay? You also need to understand the sands and the gravel, okay? The materials that go through the sieve number 4, okay? And the materials that are retained above the sieve number 4, okay? You also need to understand the mineral aggregates, okay? And the sources of aggregates. Then you look at the properties and uses of aggregates, the strength of aggregates, the shape, and the compaction, okay? We spent quite enough time to look at the strength of aggregates and the shape itself. As I said, if you have spherical aggregates and wedge-shaped aggregates, they said that there is what we call the surface area to volume ratio. So the spherical aggregates, they have very less surface area to volume ratio, which means that they have a very small surface area which is exposed to one another. And therefore, if you had spherical aggregates, it means they will have many voids in between them. If you have less contact to one another, you have higher or many voids. then you have less friction. Less friction means less strength. Okay, so if you have a smaller part of the surface area which is exposed, you have less friction, then less strength. Okay, so for the wedge shaped aggregates, they have more surface area which is exposed, so they have more contact from particle to particle, which means they have higher friction and therefore they have more strength. Okay, so you also need to know what compaction is. Okay, and how does it improve strength. Okay, so first note the definition of compaction, and the other term that is related to compaction is cohesion. Okay, so know what compaction is and be able to define compaction, know what cohesion is and define cohesion. Okay, and then know how those two terms are related to moisture content. Okay, but ideally compaction, okay, compaction increases strength. Okay, remember that compaction increases strength. So the other property is the weight of the aggregates. Okay, so the weight of the aggregate will also affect the overall strength of the material. So you don't want to have a material so heavy, because it will also affect the structural integrity of your project. For example, if you are doing a building, okay, and you are doing, say, a roof, okay, say a flat roof, and you're doing concrete, okay, so you have something so heavy, okay, on your roof, it's going to affect the structural integrity of your building, say the foundation. Okay, especially if it was not designed to carry that kind of weight. Okay, so that property is also so much important. So adhesion is another term or another property of material. First, note how to define adhesion and how it is important that you know that material property. Okay. Another property is permeability. Okay, which means some people call it hydraulic conductivity, and this explains the rate at which a material will allow water to penetrate through. Okay, and you need to know how to define permeability and how to calculate the coefficient of permeability. Okay, know the formula of calculating permeability and be able to define permeability. So the uses of our properties is some of them, not all of them. So some of the uses of our aggregates is to reprep line channels. You can use our aggregates as gabion retaining walls, as well as they can be used as filter medium. Okay, so if you have aggregates which are more permeable, okay, which can allow water to go through it easily, then such kind of aggregates can be used as gabion retaining walls, because we want to retain some of the soil, okay, and allow water to pass through. Okay, then we use a more permeable material for such kind of a job. Okay, as I said earlier, you need to know how to define gradation. What is gradation? Remember terms like well graded, poorly graded, okay, medium graded. So those terminologies, you need to know how to define them. You also need to know what uniformity coefficient is. You need to be able to define it, and be able to calculate the uniformity coefficient. Remember the D60 divided by the D10, okay? So the smaller the answer, the more uniform size aggregates you have in your sample. So if that ratio is higher, it means that your sample is less uniform. So you also need to know what the gradation envelope is. So if you plot the upper and the lower specified limits, okay, so anything that is beyond the upper, which is the D60, and the D10, which is the smaller one, so that gives you the gradation envelope. And the gradation envelope, if it's huge, it means that it has a less gradient, okay? Or if it's so close together, okay, it's so steep, right? So if it's so steep, it means that the D10, D60 is smaller, okay? So you need to understand the relationship between the uniformity coefficient and the gradation envelope. So for the physical properties of aggregates, you need to know the surface area, the moisture content, the absorption, the weight, volume relationships, specific gravity. I've explained what the surface area does, okay? Surface area is the surface area that is in contact from one particle to the other, okay? Less surface area, less friction, less strength, okay? So if you have more surface area exposed, it means there's more friction from one aggregate to another, then you have more strength. So the moisture content, it is the rate at which your aggregate is going to absorb the water, and it's related to absorption, right? And then the weight volume relationships goes together with the specific gravity, which is related to density, okay? So density is volume divided by mass divided by volume, okay? So if you have an aggregate with a constant weight, okay? So if you vary your volume, okay, then it means if you have a specific sample with a specific weight, okay, so if you reduce the volume, then your density increases. So if you increase the volume, then your density reduces, okay? And that density will also be related to the specific gravity. So you should be able to calculate density, and that's what we did in our lab last week. Basically, what we were calculating is density equal to mass divided by volume, okay? So make sure that you know how to calculate the different types and different states of moisture content. We have the often dried, we have the wet, all those types or states of moisture content, and make sure that you know them. Make sure that you know the different states or different types of gravities that we have, and how to calculate density, how to calculate volume, how to calculate weight or mass, okay? So for the mass and the volume relationships, we know that all matter has mass and it occupies space, okay? So mass, space that it occupies is just the volume, right? So volumetrics are the relationship between mass and volume. So the volume of a solid matter is important in calculating the mix properties and determining the quantities. So this is what we'll cover in our next topic, but for this exam, just know the relationship between mass and volume is mass, volume, and density, and be able to calculate those. So density is equal to mass divided by volume. So make sure that you remember this formula and be able to calculate this. Remember also that when you are calculating anything or any relationship like this, make sure that your units are the same. Okay, so if you are using pounds per feet, then everything else should be based on the pounds. If you're using the kgs, kilograms, make sure that your units are uniform throughout. Okay, so that's key. If you use different units, then your answer will be totally wrong. Okay, so the unit density of water is given as 1.00 grams per centimeter cubed, and this is what I gave you as the absolute density in our lab last week, which we converted to about 63.43, okay, pounds per kilo pound. Okay, so this is the absolute density for the water, which is what we use as a standard. Okay, yeah, that's 62.4 pounds per foot cubed. So that will mark the end of this review. So make sure that you go through the chapter 1 and the chapter 2 in your textbook. Make sure that you go through my notes or my lecture notes that I have up there on Blackboard, and be ready for the exam on Wednesday. The exam will be true, false, and multiple choice questions and some calculations as the one that I pointed out. Okay, so make sure that you know how to calculate those. Okay. Alright, I wish you the best on the exam on Wednesday, and if you have any question after the exam or before the exam, please let me know.